Hello everyone, good morning. I hope you are fine. Today we are starting our next topic of the class 9. That this one chapter energy, work energy power chapter is going on. So in last class we discussed their work done, then how you can find work done. Okay, and questions of this one topic we will solve later on. Then today we are starting our next topic energy. After the work, then we will do energy. Energy, what is energy? Energy is a capacity of doing any work. Energy capacity of doing work is known as energy. Energy always will store in form of the work done. एनर्जी किस स्टोर में किस फॉर्म में स्टोर होती है? वर्क की फॉर्म में. एनर्जी ऑलवेज स्टोर इन फॉर्म ऑफ वर्क डन. कि कितना वर्क किया जाता है, दैट इज वर्क डन बाय व्हेन एनी ऑब्जेक्ट इज गोइंग फ्रॉम वन टू अनदर प्लेस, देन हाउ मच वर्क इज डन बाय दिस ऑब्जेक्ट वन टू अनदर पोजीशन, देन देयर we will store that work done in form of the energy. That is what is a capacity to do any work. ओके कोई भी काम किया जाता है किसी ऑब्जेक्ट के द्वारा एक पोजीशन दूसरे पोजीशन पे आने के लिए, तो कितना काम होगा, तो वो जो भी वर्क डन हो वो हमारा किस फॉर्म में स्टोर हो जाता है? एनर्जी की फॉर्म में स्टोर हो जाता है. इफ यू आर हैविंग एनर्जी दैट वी कैन डू दैट वर्क, अदरवाइज वी नॉट. Okay, so energy is available in a different form. Energy having different form. For example, heat energy, chemical energy, mechanical energy, sorry, electrical energy, and these are the different form available to store the work. That is a different form of the energy available. So out of these all energy, then in our syllabus having mechanical energy. Okay, first we will do what is the unit of energy. Energy is having SI unit, joule. Okay, other unit we can say there force, kg, meter. Work done is equal to, we can write their force into displacement. So unit we can write there Newton. Meter also as a unit of this work done. Okay, energy also we can say it is our scalar quantity. It is scalar quantity. What is scalar quantity? That is a quantity which is in which we can find only magnitude, not having direction. Vector that is having direction as well as the magnitude, then we will use their energy. Okay, so here energy, mechanical energy, first in our syllabus only mechanical energy only, mechanical energy. Those energy which is due to motion of any object is known as mechanical energy. ओके, जो किसी ऑब्जेक्ट की मोशन की वजह से जो एनर्जी कंजर्व होती है, दैट इज योर मैकेनिकल एनर्जी. एनर्जी ऑलवेज हैविंग कंजर्वेटिव नेचर. एनर्जी इज हैविंग कंजर्वेटिव नेचर. Okay, that it follow the law of the conservation of the energy. Okay, so here mechanical energy having two type. Mechanical energy we are dividing into two part. One is kinetic energy, second is our potential energy. Kinetic energy and second will be our potential energy. Okay, mechanical due to motion only, so both are related with motion only, but kinetic energy due to motion of any object and potential energy will be due to change in the configuration of any object, that energy will be stored, that is known as the potential energy. Kinetic means that is your motion only. Kinetic का meaning ही क्या होता है? motion. क्लियर. सो योर काइनेटिक एनर्जी ड्यू टू मोशन ओनली. जब कोई भी बॉडी एक पोजीशन दूसरे पॉइंट तक मूव करती है तो काइनेटिक एनर्जी लगती है, जो क्या होती है? हाफ एम वी स्क्वायर. एंड पोटेंशियल एनर्जी विल बी स्टोर दैट इन फॉर्म ऑफ द mgh. मास g is acceleration to gravity, h will be height of that object. So first we will do kinetic energy only. Kinetic energy it is the energy which is act due to motion of any object. Known as kinetic energy. Okay, so kinetic energy, its assignment also will be joule only. Kinetic energy which is due to motion of any object. For example, any object we are taking here moving with some velocity, initial velocity u, then after some time it will reach here, finally its velocity becomes v. Okay, then it will be moving from here to there, then time taken during from here to there, t time. If s displacement is take place from initial to final, if s displacement is take place by this object from here to there, then total work done stored by this object going from here to there, that work done will store in form of our energy, and that energy is known as the kinetic energy. Okay, so how we can find this one kinetic energy? Let an object which is moving with some initial velocity u, and after displacement as its velocity becomes v. ओके, क्या वेलोसिटी हो जाती है? v वेलोसिटी हो जाती है. देन एनर्जी stored in form of work done by this object moving for t time, for time t from velocity u to v. Okay, so here we have to find out if any object its initial velocity is u, then moving from here to there with s displacement within time t, then finally its velocity becomes v. Okay, then we have to find out how much work is take place by this object going from here to there. So this one work done will store in form of the energy, and this one energy we call it kinetic energy. तो हमें क्या निकालना, वर्क डन निकालना, यहाँ से यहाँ तक कितना वर्क डन हो जाएगा. So how we can find their work done? As we know, work done by this object from one to another place, then work done we can write their force into displacement. Force and displacement both are acting in same direction, then theta becomes here 0 and cos 0 will give us a 1 only. So here work done will be force into displacement going here object is here, then its velocity u, then after some time its velocity becomes v. तो यहाँ से यहाँ तक की जो डिस्प्लेसमेंट है हमारी क्या है, एस डिस्प्लेसमेंट है. कितने टाइम के लिए, टी टाइम के लिए. सो बाय यूजिंग योर न्यूटन सेकंड लॉ, देन फोर्स वी कैन फाइंड देयर बाय यूजिंग न्यूटन second law, we can write their force equal to mass into acceleration. Okay, so here acceleration we can write there by using first equation of motion. Then here a we can write there v equal to here a by using your third equation, because here need of the velocity only half time v square. So by using their third equation of motion we can write here by using third equation of motion. So here we can write there v square minus u square equal to 2as. Know about this one everyone? From here we can find their value of their as. Okay, so here we can write their a equal to our v square minus u square divided by 2s. So this one our first equation, this one our second equation. So as we are putting here, put value of a in equation सेकेंड. इस इक्वेशन से ए की वैल्यू निकालेगी, बॉडी यहाँ से यहाँ तक जाने में कितना एक्सेलरेट करेगी. दिस वन एक्सेलरेशन वी विल पुट हियर. आफ्टर द पुटिंग दिस ए, देन फोर्स विल बी केम आउट. देन पुट वैल्यू ऑफ ए इन इक्वेशन सेकेंड. क्लियर? यहाँ से क्या है, ए निकालेंगे, ए निकालने के बाद कहाँ पुट कर देंगे, एफ के अंदर पुट करेंगे. तो हमारे पास फोर्स क्या आ जाएगा आफ्टर पुटिंग दिस वन, देन एफ वी कैन राइट देयर एफ इक्वल टू एम ए विल बी इक्वल टू यार वी स्क्वायर माइनस यू स्क्वायर डिवाइड बाय आवर 2s. दिस ओनली. ओके, सो हियर फाइनल वेलोसिटी माइनस इनिशियल वेलोसिटी, देन पुट वैल्यू ऑफ एफ इन फर्स्ट इक्वेशन. नाउ पुट वैल्यू ऑफ एफ इन इक्वेशन फर्स्ट. ओके, फर्स्ट हमारी क्या है, वर्क डन की इक्वेशन है. वर्क डन इक्वल टू फोर्स इनटू डिस्प्लेसमेंट. यहाँ से इसको एफ की वैल्यू यहाँ से उठा के क्या है इधर पुट कर देंगे, तो वर्क डन क्या आ जाएगा हमारे पास. सो नाउ वर्क डन इक्वल टू फोर्स इनटू डिस्प्लेसमेंट, पुट वैल्यू ऑफ एफ फ्रॉम हियर. यहाँ से क्या एफ की वैल्यू निकालेंगे, क्या निकली थी हमारे पास एफ की वैल्यू, एम वी स्क्वायर माइनस सी स्क्वायर बाई 2s. नाउ पुट हियर m v square minus u square divided by 2s, then s as it is this only. So s to s cancel out, then work done will be left here minus v square minus u square divided by 2. This one came our work done only. तो यहाँ से वर्क डन क्या आ गया हमारे पास, मास वेलोसिटी स्क्वायर माइनस यू स्क्वायर बाई 2. So as we will write there, then your final velocity minus initial velocity, then if initially velocity of an object is 0, okay, that is object initially at rest only. ओके, इनिशियली क्या है, रेस्ट पे है. मीन्स हियर वी कैन से देयर u इक्वल टू 0। इस केस का क्या मिलेंगे, इनिशियली ऑब्जेक्ट क्या है, इनिशियल वेलोसिटी 0 है, रेस्ट पे तो इनिशियल वेलोसिटी क्या आ जाएगी, इक्वल टू 0। सो वर्क डन क्या हो जाएगा, वर्क डन विल बिकम योर माइनस m u इक्वल टू 0 v स्क्वायर माइनस योर 0 डिवाइड बाई, क्लियर। जैसे हमने इनिशियल वेलोसिटी की वैल्यू पुट की है u इक्वल टू 0, तो हमारे पास क्या आ जाएगा, वर्क डन विल बिकम इक्वल टू योर 1/2 m v square. So work done will store in form of the kinetic energy. Work done will store in form of the kinetic energy. Work done store in form of the kinetic energy. So here kinetic energy we can write there half m into square. क्लियर। तो हमारे पास क्या आ गई, काइनेटिक एनर्जी आ गई कि यहाँ से यहाँ तक बॉडी कितने काइनेटिक एनर्जी के साथ मूव करेगी, दैट इज इक्वल टू हाफ एम स्क्वायर। सो आई होप यू अंडरस्टूड बेटा हाउ वी कैन सोल्व दिस वन काइनेटिक एनर्जी, ड्राइव दिस वन काइनेटिक एनर्जी। नाउ लेट अस सी वन क्वेश्चन रिलेटेड टू दिस वन। एन ऑब्जेक्ट of mass 10 kg moving with initially 5 meter per second, then after 20 seconds its velocity becomes 25 meter per second. Then find total work done by this object. Okay, so here how we can find this one, क्वेश्चन के अंदर कह रहा है कि अगर एक ऑब्जेक्ट है जिसका मास क्या है 10 kg है, इनिशियल वेलोसिटी ऑफ दिस ऑब्जेक्ट इज 5 मीटर पर सेकंड, then after 20 seconds its velocity becomes 25 meter per second, then we have to find out how much work is done by this object. ये ऑब्जेक्ट कितना वर्क करेगा। so work we can write the force into displacement, but body is moving during the motion, then energy that work done we can say will be stored in form of the kinetic energy. So we can find their kinetic energy, that kinetic energy will be equal to work done only. So as given in our question, क्वेश्चन के अंदर given हमारा ऑब्जेक्ट है जिसका मास क्या गिवन है 10 kg, इनिशियली ये मूव कर रहा है 5 मीटर पर सेकंड के से एज गिवन इन आवर क्वेश्चन, देन आफ्टर द 20 सेकंड, आफ्टर 20 सेकंड इट्स वेलोसिटी बिकम्स 25 मीटर पर सेकंड, कितनी होगी 25 मीटर पर सेकंड। सो हियर वी कैन राइट देयर as given in our question, mass is given our 10 kg, initial velocity u we can write there 5 meter per second, then time is 20 second, final velocity v we can write there 25 meter per second. क्लियर। तो हमें क्या निकालना है, वर्क डन निकालना है। तो वर्क डन कैसे निकालेंगे, वर्क डन वी कैन राइट देयर वर्क डन we can write the force into displacement also, but here force is not given in our question and displacement also not given, that's why we can use right there work done in form of the energy because velocity is given. So if they are finding the kinetic energy, then we can write their work done. So work done we can write there change in kinetic energy, change in kinetic energy. ओके, एंड दिस वन वी कैन कॉल इट वर्क एनर्जी थ्योरम। इस टर्म को हम बोलते हैं वर्क एनर्जी थ्योरम, वर्क एनर्जी थ्योरम। क्लियर कि अगर आपको एनर्जी गिवन है, एनर्जी की टर्म्स गिवन है, चेंज इन काइनेटिक एनर्जी हम फाइंड कर देंगे तो किसकी इक्वल होती है, वर्क डन के ही इक्वल होती है, दैट इज नोन एज द वर्क एनर्जी थ्योरम। तो इस थ्योरम के अकॉर्डिंग हम ये कह सकते हैं चेंज इन काइनेटिक एनर्जी मींस हियर वर्क डन वी कैन राइट देयर change in kinetic energy means kinetic energy final minus kinetic energy initial. Final kinetic energy you can write there half mv square minus half mu square. Yes, sir. This one your final velocity. This becomes your initial velocity. So that's why with it, that is the initial kinetic energy. Final kinetic energy. This one becomes your initial kinetic energy. So using this one, then we can write there half m. We can take common, then inside left v square minus q square. So here 1/2 mass is given as given in our question. See here. Now mass is given our 10 kg. Now put here 10 kg and final velocity is given in our question 25 meter per second and initial velocity is given 5 meter per second. So as we will put these terms, then here we can write there 25 whole square minus here 5 whole square, final minus initial. We will write there final minus initial. Okay, so solve this one. Here left your 1/2 into 10, 25 into 25, then 6 to 5 we can write here. Then here left here 25. 5 into 5, 25. So solve this one. Then here left here 1/2 we can write there 5. Cancel out. Then here left 6 to 5 minus 25. Then here will become your 600. So solve this one. Here will become 3000. So our change in the kinetic energy will become your change in kinetic energy will become equal to 3000 joule. And this change in kinetic energy we can write there work done. Work done equal to our 3000 joule. I hope you understood beta how we can find this kinetic energy by this one. Kinetic energy will be by using a work done. So see next question. A car starting from rest whose mass (3,000 kg), then find kinetic energy. Kinetic energy if at end of journey its velocity becomes 30 meter per second. Okay, तो हमें क्या निकालना, काइनेटिक एनर्जी निकालनी. सो काइनेटिक एनर्जी वी कैन राइट देयर, काइनेटिक एनर्जी वी कैन राइट देयर हाफ mv square. So half mv square mass is given in our question 1/2 as mass is given 3000 kg. So here we can write there 3000 kg. Initially it is at rest. Initially at rest means beta u equal to our 0. Initial velocity is equal to 0. So kinetic energy में find करनी थी. At the end its velocity becomes your 30. तो end पे क्या 30 square. So solve this one. Here will become your 3000 into your 900 divided by 2. So here will become your 21500. So here left 0000 30. This one energy will become as according to this question. So I hope you understood beta how we can find their kinetic energy, mass given and velocity given. If work done given, this one is not given, then we can find in formula work done also. Thank you for watching today our video. Have a nice day.